The fourth and final section of Chapter 2 deals with chemical reactions and enzymes. Now, a chemical reaction is a process that changes one set of chemicals into another set of chemicals. Now, the reactant is the element or compounds that enter into a chemical reaction, and the product is the result of the reaction. So the reactant goes in, the product comes out. Now, chemical reactions always involve the breaking of bonds in the reactants and the formation of new bonds in the products. So if we take a look right here, the two substrates are going to be the reactants here, the yellow or orange and green. And we see all the way to the right, the product now has a little bit of green in the orange piece. So that's going to show new bonds were formed. So we broke bonds in the reactants. The green one had bonds broken, and they were formed again, new bonds in the products. Okay? So chemical reactions that release energy often occur spontaneously. Chemical reactions that absorb energy will not occur without a source of that energy. Activation energy is the energy required to start a reaction, and a catalyst is a substance that speeds up the rate of reaction. Right? Now they work by lowering the activation energy. Now the activation energy, the energy required to start a reaction, think of it as picking something up off the floor. Right? The distance that you have to pick it up and put it to is the activation energy. So let's say you've got the groceries at home, and you put them on the floor when you come in the house, and you have to pick them up and put them in a high cabinet. That's the activation energy from the floor to the cabinet. But if you set them on a counter, they have less distance to travel, so you're going to be able to do that much more quickly. That activation energy is lower, the reaction is faster. Okay? And that's what a catalyst is going to do. They're going to speed up a reaction by lowering the activation energy. Now, enzymes are going to be proteins that work as catalysts. So they're made of proteins. We just discussed proteins. Now, cells use enzymes to speed up chemical reactions that take place in cells. Right? The reactants of enzyme catalyzed reactions are known as substrates, which we saw in that diagram before, which we'll go back to. And enzymes end in ase. All right? So protease, lipase, things like that. The suffix ase will be on them. So if we take a look back here at this diagram, it shows the enzyme in red with its active site. Now notice how it fits perfectly into that active site. All right? If the shape of the enzyme was changed, those substrates would not work, and that enzyme would be what we call denatured. Right? So enzymes are specific to the substrates they work with. They're very specific. Just like the key is very specific to the lock in a door.